Hey guys, this week's lab qualitative analysis does not have a procedure. We are going to be taking 6 different metal cations and testing them with different reagents to find a way that we can distinguish them from one another. Then we will use these observations to determine what metal ions are present in an unknown solution.
So we're going to start off with our silver nitrate solution. We don't need that much. Again, this is a qualitative analysis. It's not quantitative. We're not measuring out by mass or volume any amounts. We're just seeing how things react down the tree. So with our first unknown, our first addition down the tree will be hydrochloric acid.
That looks like a precipitate.
That is definitely a precipitate. Oh yeah.
So it formed a precipitate.
Yes. So we're moving down the left side of that reaction tree. We'll now test its reaction with ammonia. If the precipitate dissolves to make something new, which we could qualitatively observe again as a new color or new dimensions to the precipitate, then we would know it goes down the left side of that branch.
It dissolved.
If it dissolves, it goes down the right.
Very cool.
So none of this should be too surprising. We have seen already that silver chloride is a solid, if you recall from your solubility rules. We have also seen, I believe, from the chapter on equilibrium, that a silver ammonia complex is aqueous. Now we're ready to move on to our zinc nitrate.
And you guys can actually see for the silver, we skipped the last step because it just wanted us to add hydrochloric acid again, which would just get us a precipitate once again. So we didn't have to repeat that step.
Right. So to our zinc, our first step will be adding the hydrochloric acid. We're going to see if it forms a precipitate or not.
And this is going to be our first step every single time. We're always going to be adding this hydrochloric acid as see what forms.
Yep, no precipitate. So now we're moving down the right side of the first branch of that reaction tree. Next step will be to add sodium hydroxide. It's the same concentration of the hydrochloric acid, so we'll need about the same amount to neutralize that acid, and then we'll add a little more to see if the precipitate forms.
Starting to see something.
Yeah.
It's looking cloudy.
Because not so much has been added yet. It may be that it goes away. Oh, it doesn't. It sticks around.
Would that be a zinc hydroxide?
Zinc hydroxide, yeah. If you recall from your solubility rules again, zinc hydroxide is insoluble. We're going to add an even stronger, higher concentration of sodium hydroxide to see if this redissolves. If it dissolves in the presence of additional base, making a higher hydroxide complex, then it will be amphoteric. And we've demonstrated there, as it's redissolved, that this is an amphoteric species.
And can you just jog my brain again? What's amphoteric mean?
Amphoteric means that this species behaves as both an acid and a base.
Wicked.
It's like an amphibian.
Yes.
For all those who love root words.
And the chemistry sense.
Or amphidextrous.
On to our third unknown, cadmium nitrate. We're going to, again, first step is add acid. We keep adding a lower concentration of acid, just 1 molar to start. Though we have 1, 3, and 6 molar acids available, if we start with 6 molar, we're going to have a lot of base to add to neutralize it. So we're going to start with 1 molar.
So cadmium chloride would be soluble.
Yeah. Yeah. But again, from our solubility rules, we could predict that cadmium hydroxide would be insoluble. And when we add our base, we can see that, yes, we are getting a precipitate. So confirmation of our suspicions. Now we'll up the ante with some more concentrated sodium hydroxide to see if cadmium hydroxide is also amphoteric, like our zinc was.
It doesn't appear so,
Nope.
but
Yeah, more addition of base. It's just still solid, suspended in solution there. So now we're moving down the right side of our second branch there, of our decision tree, to the addition of acid to redissolve the precipitate. Let's get back our cadmium chloride, which is aqueous.
And this is 6 molar, so it's strong.
Right. And we need a lot of strong acid to neutralize the strong base that we had just added.
So we're adding tin chloride next?
Yeah. To this solution, we're going to add our tin chloride to see if a redox reaction will happen.
What's a redox reaction?
Where we have the transfer of electrons from one species to another. So one species is losing electrons, another is gaining them.
Oh, you mean an oxidation reduction reaction.
Right. That'd be the
redox.
The
redox.
full term.
That's their celebrity couple name. Redox.
like Brangelina. Ooh, I can't say that anymore now though.
Oh.
Sad.
Well, you never know.
Everything's cyclic.
I don't see a precipitate.
Right, so we are placing cadmium on the right side of that final branch of our decision tree.
Looks like cadmium hydroxide.
Apparently.
It's cool. It's like a snow globe.
So we'll notice that our tin chloride solution there didn't change anything. We had just neutralized the acid and then we added more base to get back our cadmium hydroxide and finished with that. Now we're on to mercury 1. We're going to see where this falls in our reaction tree. Mercury 1, by the way, when we say the name, the 1 there refers to the charge on each mercury atom. Each mercury atom in this solution has a 1+ charge. But the subscript on the mercury, when we see it in molecular formula, is 2, Hg2, because it's a dimer, it dimerizes. So you'll see it in a formula as Hg subscript 2, superscript 2+. We add the acid and it does form precipitate. So we're going down the left side of the reaction tree. And now adding ammonia to see if it dissolves or creates a new precipitate.
That looks like a new precipitate.
Yes, it does.
It's nice. It's like a black.
Yeah, black, gray. There might be several things present there. We'll talk more about the mechanics of each reaction at the end of the procedure here, as we're just kind of blasting through this procedure. We're moving through it pretty quickly. Mercury 2 is what we're on to now that we've placed mercury 1 on the far left side of the reaction tree. We're doing our first addition of acid. Again, keeping that concentration lower so that we don't have so much work to do in neutralizing it later. No precipitate forms when acid is added to mercury 2. So we're moving down the right side of the reaction tree and adding sodium hydroxide.
It's a nice color.
Ooh, lovely.
Some mercury 2 hydroxide.
And it disappeared, so we'll see if adding a little more makes it come back and stay. It might just not have been enough base to keep it around in solution. Now again, upping the ante to see if this is an amphoteric species as well. Again, if it's amphoteric, it will react with more base. we know that we could add acid to get back our aqueous solution. If we can get that aqueous solution from adding base as well, then it's amphoteric.
It's
not.
the same.
Yeah. In this case, it's not. So, not amphoteric, we're moving down the right side of the second branch there. We're going to add a higher concentration of acid to dissolve that. Now that we know it's on that side, we want to get the aqueous solution back and see how it'll react with tin chloride. So we've got back our mercury 2 aqueous now. And we're going to add our tin chloride.
Looks like a snow globe.
Clear reaction. And notice that that actually looks like the same precipitate we saw when we added acid to mercury 1.
Interesting.
Are you suggesting that could be the same precipitate, or it just looks like the same precipitate?
We'll see that it is in fact the same precipitate, although the silvery color of this tells us there's something else present as well. What happens here is actually a disproportionation reaction, where we get back both mercury metal and mercury 1 from that reaction.
So it's really more of a mercury color.
Both mercury and the white mercury 1 precipitate, yeah.
All right, now we're moving on to the unknown section of the lab. Make sure in your lab notebook that you do write unknown B to get full points.
Unless you don't want full points.
Yeah, which,
Hey, maybe not everyone does.
more power to you.
So in our unknown, we're going to have several of these 5 cations that we've already looked at. We're going to have to find out which ones we have by reacting down this reaction tree and separating out each time precipitate from aqueous solution.
So it makes a precipitate when you add HCl.
Yeah. So we know we have either the silver or the mercury 1. We've got to centrifuge that off now, because we know that if we had zinc, cadmium, or mercury 2, they would not form a precipitate. They would be still aqueous, dissolved in solution. We have to separate then the aqueous part from the solid.
So just to be clear, the unknown has multiple cations in it.
Yes.
Okay, so basically what you're saying is that we have our reaction tree and we have a precipitate, so we're splitting them up into 2 different test tubes. One that formed a precipitate, and then the other, which is still in solution.
Yeah.
And we'll put that into another test tube.
Right.
Cool. Process of elimination.
Right. So at the bottom of the spun down test tube here, we have the solid, and then the liquid on top of that is called the supernate. That could contain zinc, cadmium, or mercury 2. We don't know, so we have to separate it off.
Cool. Yeah, so that supernate then would be the right side of our reaction tree. Right. Any of those possible.
Oh.
Just butterfingers over here, yeah.
Cool. And then that white precipitate that we've centrifuged down, that is the left side of the reaction.
Yeah, we'll test that one with ammonia, and on the right side we'll test with sodium hydroxide.
Cool. So just a process of elimination now. Our unknown for sure has 3 different ions in there. We just have to figure out what 3 they are.
Right. It could have only 2, I think. Some of the
How would
ions
we
have
know
only
it's
2.
3?
Oh, I saw in the answer key.
Oh.
all of the unknowns only have 3.
Okay.
So I guess you could just stop watching the video now and just kind of
Wildly guess?
Yeah, 3 out of 5 chance. Huh?
It's probably not good odds.
No.
Hey, we've got that black. So what was that from our observations? Which you guys are all recording meticulous observations, I'm sure.
Absolutely. Color changes, any funny jokes we say.
Yes, that's good observational data.
So that's definitely a mercury, right?
Yeah, that was the mercury 1 that we saw.
Okay, cool.
That looks oddly familiar.
Yeah.
That's a new clip. So we could have both, just on that left side of the table, we could have both mercury 1 and silver. Right? Remember, the silver was aqueous with ammonia, whereas the mercury 1 was not. It made that black precipitate. So we have to separate this off too. Pour the supernate off, which could have silver, and test for silver, and then hang on to that pellet, which has the mercury 1 for sure. We know about that.
So this would be a good lab to really practice your organizational skills, right? Labeling all your test tubes, because you could definitely mix these things up and get kind of lost and have to start over. Thankfully, we kept very good track of it for you.
Whatever you do in life, it's always good to have good organizational skills.
Mm-hmm.
It's my life advice for today.
This is why I'm struggling with life. My lack of organizational skills.
I'm sure there's a time where it pays to not be organized.
Lord, let that time come swiftly.
Like shuffling cards.
All right, so we've got our mercury 1 solid there, and we're going to test for silver in the supernate. I think here I was thinking I would add ammonia, but then decided against it because there should already be sufficient ammonia in solution.
Maybe you went away to go to the bathroom.
Taking a break. We'll probably edit this part out.
Yeah. Or not, maybe give you
Just could leave it in.
Yeah, a chance to catch up.
Oh yeah, make some observations. Have some elevator music playing.
Pop some popcorn.
Mm. Okay, so this should be hydrochloric acid, right? There's our supernate.
Yes.
Right, it could have silver.
1 molar.
Great, we're going to test it with hydrochloric acid.
I'm not seeing this precipitate.
Right. If silver was there, it would make silver chloride, a white precipitate. It's not there.
So you're saying is we don't have silver.
That seems to be the case.
So now we have a good chance.
Yeah, 3 out of 4 chance. Stop the video right now and guess.
But it's more complicated than that, right?
It is more complicated than that. This is chemistry.
Yeah.
This is qualitative analysis. So, Professor Schultz, what's the difference between qualitative and quantitative?
Qualitative analysis, you're just looking for general clues as to what might be present. Precipitates, colors, heat, cold, big changes. Whereas quantitative, you're just doing a numerical or empirical analysis of.
So you're looking at the
Substance.
quality over the quantity.
Yeah, I guess.
It's a good way to remember it.
It's probably how they got their names.
Yeah, that would make sense.
So to the supernate from the first branch in the reaction, we are adding sodium hydroxide. Remember, in this side there could be zinc, there could be mercury 2, and there could be cadmium.
Wait, I recognize that color.
Yeah. If we were taking good observations, which of course we would have recognized that orange as being the mercury 2. So we know that's present for sure. And because it's such a strong color, it could just be overwhelming any other precipitate that would form in there as well. So we'll have to do some separating of this as well. Spin down the solid and pour off the supernate.
Just to make sure there's no other ions in there. Yeah.
So here we go. We're going to test, just to be doubly cautious, we're going to test that mercury and potentially cadmium with additional sodium hydroxide for any amphoteric behavior. I don't think this was really necessary at this point because we added enough base in the first step, and the amphoteric species should be in the supernate on the right there. If there was an amphoteric species present. In fact, we tested that off screen, and there was no amphoteric species. So zinc is not actually present in that test tube. It's just a supernate of various spectator ions. So we're going to focus our efforts then in the test tube, the orange test tube on the left here. We're going to have to add acid to redissolve it, and then add our tin chloride to see if we get, another precipitate, but remembering that we could also have both the species that formed a precipitate, the mercury species, mercury 2, or we could have the cadmium, which did not form a precipitate in this last step, addition of acid and addition of tin chloride. So notice that precipitate we did have, the orange one, it did dissolve. We have a bit of a white precipitate here showing up. This probably is just carryover from the mercury 1 that we found earlier. Our separation process here isn't perfect, so we can get a little bit of contamination, cross-contamination from supernate to test tube. So we're not going to take that too seriously, as we've already tested in under acidic conditions. So we've redissolved the solid that we had, and we're going to add tin chloride to that to see if we get a new precipitate.
It appears we do.
Yeah.
Looks like it's changing colors a little bit.
Yeah, it started off white, and now it's making that silvery, the metallic mercury.
The mercury color.
Yeah.
Wait, I recognize that.
Right.
Looks like mercury.
Qualitatively.
So recall too, though, that cadmium didn't make a precipitate when we added the tin chloride. So in the solution, there could still be cadmium present. We'll have to test for that. Yeah, we're going to centrifuge it down. The pellet will have the mercury. If cadmium is present, it'll be in the supernate. So we'll pour that off and test it for the presence of cadmium by adding sodium hydroxide. So the pellet is really hard to see in this, but it is there. We saw the solid in the test tube, and it's been spun down. So we're pouring off the supernate. If cadmium is present, it'll be in there, in the test tube in my left hand. In the right hand here, we have confirmed several times over the presence of mercury. So we're going to test this supernate, see if that cadmium is present by adding our sodium hydroxide. A higher concentration of it, 6 molarity, just because we were adding highly concentrated acid in some of these earlier steps. We don't want to waste a lot of time trying to neutralize it, so we're just going for the big guns. And there we see our precipitate form. So confirmation, cadmium is present in our unknown mixture as well. So we've confirmed the presence of 3 different unknown species. You can scroll back through the video if you want to remind yourself of any of those.
Or just watch for fun.
Yeah.
Yep. Maybe just watch this before bed each night to remind yourself how much you love chemistry.
I may do that.
Do a quick comparison of these unknown ions to the knowns that we determined. Here was that black precipitate that formed on the far left side of the reaction table.
And it's kind of hard to see because the smaller test tube's been centrifuged down to a pellet. But
Yeah, that's true.
same with this one as well. A little difficult to see,
A
but
little grayish precipitate on the right side of that reaction tree that formed.
Almost.
almost did a Steve.
And another white precipitate that formed on the right side.